Alright, so I wanted to add on a little bit to um, pre-calculus's discussion on functions and their graphs. And the two things that I want to add on are even functions and odd functions. Okay, what are these things? Alright, so well, let's just get talking about it. I'm going to change my pen color a little bit. So since we know what a graph is, let's just look at a graph. Even and odd is very, it's easier to see in a graph. So let's look at something like y equals x squared, and let's graph that. Okay, now there's a definition for an even and odd function, and I'd like to draw that out of the graphs. Okay. That's fine. Okay. So let's start plotting some points and we'll connect them all. So if we put in a 1 and we square it, we'll get a 1. We put in a 2 and we'll square it, we'll get a 4. 3 gives us a 9. There's a 9. Okay. Now how do we draw the rest of this? Well, we're used to this by now. We know that these points repeat themselves. They get reflected back over here. And this is a big part of evenness, okay? The graph. Okay, I want you to again distinguish between functions. Particularly, I want you to distinguish between equations and graphs. Okay, so I wouldn't say that an even function is reflective about the y-axis. It's not. The graph of an even function is reflected about the y-axis. Okay? So that's an important distinction to make, because just that we get used to separating functions, equations from their graphs. Okay, this is the graph of this. Alright? And I guess also because there is a definition for the graph, the way we see the graph of an even function, and what an even function actually is defined as. Okay, so an even function is reflected about the y-axis. Easy enough to see. Okay, it's when we start writing the definition for an even function that it starts to get a little weird. All right, so let's look at it this way. If I put in, let me grab a different color, like red. If I put in a number here, and I look at the y value here, okay, because it's reflective, what do I know? Well, if I come just as far over on the x-axis here, and I go up and look at the y value, you know, you're going to fudge it a little bit. It should be the same, right? It is reflected. It should be the same. So if I go out this far on the x-axis, I should come up this much, and if I come over just as much in the negative direction, it should also be right at the exact same y value. Okay? So this value here is x, and this value here is f of x. Right? If we know our function notation, which we should, f of x, that means basically y. You know, what does the function produce when I put in x? This is what it produces, the y value. Okay, now if this is x, and this is just as far away from the origin, what would the value of this be? It would be exactly x, but it would be negative of that. Okay, so if I put an x, I get out f of x. But what happens when I put in the negative value of that x? What is the y value that I get? It's exactly the same. It's f of x. Okay? So an even function just says that f of negative x is equal to f of x. Okay? Of course, this goes without saying. X equals f of, or let's see. Y equals f of x. The y value is f of x. If I put an x, the thing that I get out is f of x. Okay, but also if I put in f of negative x, if I take that same x value, put a negative on it, put it into the function, I'm going to get out the exact same thing. And that certainly holds true in the picture. If I put in x, I get this. If I put in the exact opposite of that, I get out the same thing. Okay, so let's look at an odd function. An odd function goes like this. Here is, I don't like that color for a long time. Just for a little bit is okay. So, let's say y equals x to the third. Here's another example. And let's graph that and see what it looks like. Sorry for that little interruption. Here's the graph of this function over here. Alright, now let's start with 1. Put in a 1 into this function, I cube it, I still get a 1. So at 1, this function produces a 1. At 2, 2 times 2 is 8. It goes right up to the top. Alright, and this is getting pretty big. Let's call it quits on the positive side. If I put in a 0 and I cube it, I'm going to get a 0. Now let's see what happens to this guy as we go the other way. Put in a negative 1. Let's look at it over here. Negative 1 times negative 1 times negative 1. What's that going to be? Negative times negative, this is positive, times a negative, positive times negative, negative 1. 1 times 1 times 1 is 1. Alright. There we are. There. Negative 1 gives a negative 1. Let's try negative 2. Put in a negative 2. Negative 2 times negative 2 times negative 2 is going to be 8, but it's going to be negative because we've multiplied 3 negatives together. And I believe I made this negative 8. Okay. So let's connect the dots here. Something like this. But nicer. There we go. So now let's look at this graph and see what the implications might be for the definition of this kind of function. First let's study the shape here. Let's say that I come out to some x value like we did with the last one. Right there, because this gets pretty big pretty fast. And here is the y value. Here's x again. Here's f of x. Let's go just as far over the opposite direction. We're going to fudge it a little bit because we know what it's supposed to look like. Okay. There's x again. This is negative x then. From our 1 and positive 1, negative 1, negative 1, positive 2, positive 8, negative 2, negative 8. We can see, or we can kind of assume that as we keep putting things in here, where putting in positive x is getting out these positive y's. We put in the negative of that x, we'll get exactly the negative of the y that we got. So we see this relationship between x and negative x, f of x, and it's just the opposite of f of x. So what it says is if we put in x, or negative x, if we put in negative x into the function, it would be the same as if we just took x and put it into the function and made it negative. Okay, that would be an odd function. And up here, this gives us an even function. Okay, so even and odd, and that's what I wanted to just add on to in this video.